Bismillah ar-Rahman ar-Rahim. Honorable Chair, dear audience, before starting, I would like to thank the organizers of this conference, ECSSD 2021, and all the audience for attending this presentation about our research paper entitled Towards a Dynamic Model of Business IT Alignment Using Enterprise Architecture, a Comparative Study. This paper is co-authored by Iman Tahiri, Professor Karim Doumi, and Professor Ahmed Zillou, and presented by myself, Iman Tahiri, PhD student in INSIAS Mohammed V University in Rabat, Morocco. This presentation is structured as follows. First of all, we introduce the topic of our general problematic related to dynamic aspect in EA. In section 2, we present the initial dynamic orientation as handled in the traditional EA approaches. In the third point, we will explain the purpose of our comparative study. An overview of our 6 selected approaches is presented in section 4. After that, we will conduct a comparative study between our approaches based on our selected criteria, and we will conclude by summarizing the main results and future work. In an unpredictable and ever-changing world, especially with the new requirements and constraints of the pandemic, enterprises are increasingly aware that the right decision must be made at the right time to maintain their sustainability and competitiveness. For this purpose, the enterprise should be prepared upstream to be future-ready. Considering that enterprise architecture is the main instrument ensuring this alignment business IT, organizations must adopt a dynamic EA approach able to respond to the ever-changing condition, taking up the challenge to compromise the reliability of the modeling, implementation, and measurement of this complex paradigm on EA, taking into account the dynamic aspects from multitude perspectives. Let's have an overview through the interior works of De Vries, exploring the dynamic aspect in traditional approaches. Zachman uses primitive models that will be created, updated, and reused when a new requirement emerges. The FEA uses segment architecture maintenance to ensure continuous updating of architectural changes and their impact on the work product segment and the management plan program. According to the TOGA framework, the requirements management phase of the iterative EDM addresses the interaction between EA components to ensure continuous alignment. In addition, gap analyses are performed periodically to allow their placement. Finally, GEAM uses a multi-phase iterative and nonlinear process model to address the dynamic condition affecting the future state of the organization. Periodic alignment initiative can also result from a gap analysis. Thus, we can see that all these selected studies introduced the dynamic aspect in a superficial way that doesn't consider the depth of these aspects. For this reason, we have conducted a systematic mapping review combined with the PRISMA statement to select the more relevant studies dealing with dynamic aspect in EA, with clear purpose of conducting a comparative study between the 6 approaches with the perspective of building a reliable and integrated model taking into account the dynamic aspects from multitude perspective. In the next slides, we will have an overview about each of our 6 approaches. Let's start with the dynamic service-oriented EA. DNCA is based on the service paradigm as predominant logic. In this approach, EA is considered as a system of services composed of a set of encapsulated services interacting with each other to create value to and with an actively involved customer called prosumer, as we can see in figure 1. The service system is derived from the 3 dimensions of a service, functional properties, non-functional properties, in addition to meta-services, to manage the functional and non-functional properties on the service, implementing thus the changes in service requirements. As limit of this approach, we can say that the notions of capabilities are not breaking down to reveal its dynamic aspects. Let's move on the EA dynamic alignment model presented by Coffey in 2017 that predicts by unfolding the life cycle of EA implementation 4 fundamental dynamic patterns induced by the different components of EA and the influences they have on each other based on the perspective triggering change. 2 indicators are identified to analyze the evolution of the alignment between perspectives over time. 1. Controlling forces for alignment, which is an indicator of the force applied to each EA perspective to achieve alignment with its constraining perspective, and alignment need rate that stands for the speed of the EA perspective's attempt to achieve alignment with its constraining perspective. The combination of the different sizes of this pair of indicator give rise to four behavioral patterns as shown in figure 2. Now, each pattern is reconciled to one of the following steps of the EA process, and each step is related to the enterprise transformation cycle step: governance, strategy, operation, and lobbying. As limit of this study, we can consider that it doesn't propose a mechanism or a frequency of application to support even the unpredictable changes. Our third selected approach is DVC for Dynamic View Capabilities, presented by Van de Wetering in 2020, who defines the Dynamic Enterprise Architecture capabilities as the dynamic capability that helps organizations to identify and implement new business and IT initiatives to ensure that the organization's assets and resources are up to date and aligned with the business and able of meeting its need. Based on this definition, three main categories of the scope of EA-based capabilities are identified to follow the changes in environments and maintain the competitiveness of organizations. 1. EA's detection capabilities to detect and identify new business opportunities. EA mobilization capability refers to the ability to use EA to assess and select potential solutions and mobilize resources in line with potential solutions. Finally, EA transforming capability. It's the ability to use EA to successfully reconfigure business process and IT to commit a combination of resources and to adjust respond to unpredictable changes. This approach doesn't bring a design or a model to the EA dynamic problematic. Our fourth study is a projection of chaos theory on EA planning, discussing the analogy between those two fields in order to contribute to a better understanding of the complexity of the dynamic aspect in EA planning by deriving the requirements for EA planning methods. It demonstrates that the results of the chaos theory as an explanatory study can provide lessons for a future structuring of the area of EA planning and enrich the existing knowledge base in the field of EA planning and could orientate a potential new construction method, even if the contribution of this paper is purely explanatory and not oriented construction for a model. We have selected here some presentation related to the application of chaos theory properties in the EA planning, like the sensitivity to the initial condition, discretion of change, trajectory, and attraction in the EA planning. Coming from the Malaysian government work developing its own governmental EA, MyGov EA, which provides a common language for all the stakeholders, the dynamic EA metamodel is based on the concept of complex cognitive activities, CCA, that facilitate fulfilling the objective by creating EA metamodel as a master EA reference in analytical manner with the principle of generalization. Then, EA models are personalized depending on the specific business cases and archived in an EA repository. This achieved through layers of applied dynamic design, physically, visually, functionally, and conceptually, and the use of Archimedes representation. Actually, this approach is fully oriented to metamodeling and treats the modeling facet. However, it could be strengthened by implementation and measurement phase in a perspective of continuous improvement of the proposed metamodeling. Now, let's have an insight into the dynamic enterprise architecture developed at the Kochi in the Netherlands. It's a revolutionary approach that advocates a programmatic, just enough, just in time. No architecture is designed until its need. It focuses on concrete business initiative instead of abstract and changeable versions. As limits, this approach doesn't involve any long-term strategic planning other than individual business initiative, and it lacks formalism and documentation. Now, after having an overview about our six approaches, each of them treats the dynamic aspects in a different way, following a different logic. Naturally, each approach has its advantages and situation with its better applied. To develop a comparison matrix of our approach, relevant criteria are to be identified, helping to understand the dynamic aspects as adopted by each of our studies. So, to define the evolution criteria, we started with an overview of what the dynamic aspect is. In this study, through the definitions and anterior studies that qualified some important criteria that should be taken into account, and some more sub-criteria that brings more precision on the nature of the factor. Through this definition and works, we can identify four categories of the main criteria for evaluating the dynamic aspect in EA: the triggering factor of the dynamics, the advantages, the coverage of the EA life cycle phases, and generic criteria such as reference and theory of inspiration, perspective, etc. In this table, Each of our approaches is based on a reference model and influenced by a theory that models understanding and point of view of the dynamic aspect in EA. The service's point of view is a natural result of the service-oriented EA and service-dominant logic background. The perspective view is used in dynamic pattern-oriented approach as it relies on Zachman framework, well known for its six perspectives. The decomposition to the four layers of dynamic design according to the CCA with Archimedes representation is used in the dynamic-oriented metamodel approach. Mostly approaches attempt to maintain alignment between strategy resource, strategy IT, business IT. Other specific approaches try to ensure interface alignments in dynamic pattern-oriented approach or dynamic reality with representation in chaos theory and mental model of information with cognitive goal and emergence of information. In the following table, we present other criteria to characterize the triggering factor of the dynamic. Is the trigger of the change internal or external to the company? Is it already planned or not planned? Dynamic aspects highlighted, the component, the driving force ensuring the dynamism in the approach, the dynamic criterion highlighted. As we can see, most approaches deal with internal and external factors of dynamic, predictable and unpredictable. Dynamic pattern-oriented model focuses on predictable factors only, unlike the CIA, which deals with unpredictable and just-in-time events. For the highlighted dynamic aspects, each of the six approaches focuses on a different aspect of the other, meta-service, dynamic behavioral pattern, dynamic capabilities, etc. We can conclude that each approach stressed special aspects of dynamic in EA based on the nature of triggering factors, external or internal, and predictable or unpredictable. The following table illustrates the action phase of EA focused on the study. The DNCA dynamic pattern-oriented model and the dynamic meta model focuses only one phase. Chaos theory and DVC treats two phases. DAA treats analysis, design, and implementation, but no one deals with the dynamic aspect in all the phases of the life cycle of EA. Overall, the selected approaches do not cover all phases of the EA life cycle, but in general, they focus on planning and analysis, which is the basis of the rest of the life cycle phases. In this table, a grade of advantages has been listed for this approach. Low coupling and highly cohesive are the main advantages of the dynamic service-oriented EA. Innovation, agility, flexibility, and reactivity are the most common advantages between our six approach. The explanatory studies ensure a deep understanding to delineate dynamic EA capabilities to bring organizational benefits. Coherence and semantic rigor for communication and documentation are the key characteristics of a dynamic metamodel. DIA remains the most pragmatic approach from the six selected. Since it's a complex paradigm, we tried in our study to explore some facets of the dynamic in EA. As can be seen, the dynamic aspect in EA differs depending on the prism of decomposition adopted, service view, perspective view, layer view, etc., the nature of triggering factors of EA dynamism, external, internal, and predictable or unpredictable, and the highlighted elements of dynamic, the skull we are focusing on, inter-enterprise, intra-enterprise, holistic vision or dynamic components, and the action phase studied in the EA, planning, analysis, implementation or measurement, and finally the targeted advantages that oscillate between the flexibility, reactivity, semantic rigor, innovation, etc. As future work, we attempt to fill in the gap that emerged from our comparative study. In the absence of a comprehensive framework that combines all end-to-end aspects of the EA lifecycle, our goal is to provide an integrated approach, combining the crucial evoked aspects of EA dynamics to reap the benefits from our exposed approach that are not contradictory but complement each other to build a multi-dimensional framework on the dynamic aspect on EA. And thank you for your attention.